Hello learners, I welcome you all to Dr. Diva Patil Vidyapit Center for Online Learning, and we are learning statistics and quantitative techniques. Are the slides moving? Can you see the moving slides and can you hear me? Just confirm in the chat box. Can you hear me? Okay. So this is statistics and quantitative techniques. And we are learning unit 4 and we try to cover unit 4 and 5 in this session. So unit 4 is related to correlation analysis. In the previous session, we have learned about the measures of dispersion. So we have learned how to do the calculations for variance, standard deviation. In this unit, we are starting with the correlation analysis. So let's see what is the correlation analysis. So correlation is a linear association between two random variables. So in correlation, so what we are learning here in this session is about the linear correlation. Okay, linear correlation. So we are checking whether the two variables are associated with each other or not. They are linearly means there is straight line relationship exist between two variables or not. That we are checking here in this correlation. Okay. So here you will observe the pair data. So what kind of data you will have? You will have the data like you have X with data for X and Y. Okay, so you will have a pair data here, X, Y. What happened? So XY data you will have. What is meaning of this? You will have the, let's say X is you're measuring the height of the student, and for the same student, you're measuring the weight. Okay. So such kind of a data, we are calling it as a pair data. Okay, so you will have the pair data here and you are finding whether X and Y are related or to each other, or is there any association exist between the two variables X and Y. Okay, so correlation analysis show us how to determine both the nature and strength of relationship between two variables. What is meaning of this? So nature means with you have the data of two variables, right? So we are calling it as a you have a pair data, we are saying. So you are interested in knowing whether there is a relationship exist between two variables or not, and that is a correlation. Now, correlation coefficient tells you about the nature and strength. What is meaning of this nature? Nature means when you have two variables like height and weight. Generally, as the height when the height is more, the weight is more, so there is a positive correlation or positive association you can see between these two variables, that we know that if the height is more, generally the weight is more. So it is possible that heighted person is slim and having less weight, but this is a general phenomenon. It means the more the height, more the weight is. So you can say there is a positive correlation exist between two variables. Okay. Now, if two variables are the time spent, the students spending time on the watching TV and at the same time his examination score in percentage or his percentage score. So more time he spent in watching TV, lesser the score he will get. Right, so there is a negative correlation between two variables. So if you increase one of the variable, if the second variable is decreasing, you're saying there is a negative relationship between two variables. Or if you increase the first variable, second is decreasing. If you decrease the first variable, the second is increasing. When he spends less time in watching TV, maybe he is spending more time in the study and his score is better. So you can say that there is a negative correlation exists between these two variables. Or time one spends in running in the gym. Okay, so and his body fat. So more time he's is spending in the gym. Maybe he is more fit, having less body fat. there is a negative correlationship between these two variables. So by looking at the two variables, you want to know whether there is a positive correlationship exist or negative correlationship exist between two variables. And you're also interested in knowing the strength of relationship. Means if two variables are related to each other, how much they are related. What is the strength of their relationship? Means if you change one of the variable, in what percentage or how much the second variable is changing, that you also interested in knowing. And that is the strength of relationship between two variables. Okay, so when variables are dependent, correlation is applied. So when you have some kind of relationship between two variables, you can find out the correlation, and the value of the correlation coefficient always lies in between 0 to 1. So zero correlation indicates that there is no relationship exists between two variables. -1 correlation means perfect negative correlation. +1 correlation means perfect positive correlation. So your value of the correlation coefficient, we generally denote it by the small r, and it takes the value from +1 to -1. So if value of r is out of this range, is greater than +1 or less than -1, you have done some mistakes in calculation. So value of r, value of correlation coefficient always lies in between +1 to -1. So types of correlation. Now let's see the types of correlation. So there are 3 types of correlation. In type 1, we divide the correlation like positive, negative, and no correlation. So we say the positive correlation exists between two variables when both the variables are moving in the same direction. Like if you increase the one variable, the second variable is also increasing. Or if you decrease the first variable, the second variable is also decreasing. So you are saying that they are in positive correlation. They are moving in the same direction. Okay. Negative correlation exists when you increase the first variable, the second variable is decreasing, or you decrease the first variable, the second variable is increasing. So both the variables are moving in opposite direction. That time we are saying there is a negative correlation exists between two variables. And there are some cases where there is no correlation exists between two variables. Okay, so you are saying there is a no correlation, or the variables are independent. There is no relationship exist between two variables. Like if you have one variable, like a number of coffee cups one needs in a day, and his shoe size, there is no correlationship exist between these two variables, right? Two variables are completely different. They are independent. You cannot say more coffee you drink, your shoe size is more. No relationship, exactly no relationship between two variables. So you're saying such times you're saying there is a no correlation exist between two variables. So I think you're clear with what is the positive correlation, what is the negative correlation, and what is the no correlation. So the second way in which we are dividing the correlation is the linear correlation and non-linear correlation. So in this particular unit, what we are learning is the linear correlation. Means if the two variables are related to each other, they are related by the straight line relationship. There is a straight line relationship exist between two variables or not, that is stated by the linear correlation. And if there is a no straight line relationship, they may follow the relation in the curve. So that time you're saying non-linear correlation exists between two variables, but that we are not studying in this particular unit. Okay, so non-linear, when plotted on the graph, it is not a straight line. When you plot the points on the graph, you will not find a straight line, and that is that type of a relationship you're saying as a non-linear correlationship. So the third type, you can divide it in the simple and multiple and partial correlationship. Oh, okay. So one independent and one dependent variable. So when you are finding the relationship between two variables, simple correlationship. If you are finding the relationship between one dependent and more than one independent variables, that time multiple variables are involved. So multiple correlation. Partial correlation, one dependent variable and more than one independent variables. but you're considering others at constant and you're just checking the relationship between two variables. So that is a partial. So we are not going in detail in this. In this unit, we are just learning about the linear correlationship, whether there is a linear correlationship exists between two variables and not. And these are the methods of studying correlationship. So whenever you are studying the linear correlationship, you can study it by these three ways: scatter diagram method, Karl-Pearson's coefficient of correlation method, and Charles rank correlation coefficient. Okay, Charles Spearman's rank correlation coefficient method. So basically what I'm trying to tell you is, if you have the variables like X, you have the variable like Y. Like, so let's X is taking values like, this is a hypothetical example I'm taking, 2, 4, 5, 7, and let's Y is taking values like 1, 2, 4, 5. So you have here the pair data, like 2, 1 is one pair, 4, 2 is another pair, 5, 4 is third pair, 7, 5 is fourth pair. So you have the pair data with you. What you are doing, you are plotting these points on the graph, on the Cartesian coordinate system. You have x-axis, you have y-axis. So what you're doing, you're plotting x, y. So first let's see this. Then your first point is 2, 1. So you're plotting 2, 1. The second point is 4, 2, right? So you're plotting 4 and 2. Then 5, 4. 5 and let's say 4 here. Then 7, 5. 7 and 5. So whenever you plot the pairs on the graph, and you can find out that you can draw a line passing through it, not passing through all the points, but tentatively all the points are located around the line. That time you are saying that there is a correlationship exists between X and Y, and which is a linear correlationship. Okay, so you're plotting your points on the graph, and that technique is a scatter diagram. So we'll see this in detail. So scatter diagram is a plot, also called as scatter plot, scatter graph, scatter chart, scattergram, or scatter diagram. All are synonyms for the same thing, scatter diagram. Okay, is a type of plot or mathematical diagram using Cartesian coordinates to display values of typically two variables for the set of data. So you're plotting the points on the Cartesian coordinate system, and you're checking whether tentatively you can find out any relationship, straight line relationship between two variables or not. And that is the scatter diagram method. So it will give you just idea about whether there is a positive correlationship exist or negative correlationship exist. In scatter diagram, you cannot find the strength of relationship, how much they are related to, how much they are associated with each other. That figure you cannot find using the scatter diagram. Okay, for if you want to know that actual number, how much they are associated with each other, you need to use the second method, and that is Karl-Pearson's coefficient of correlation method. Okay, so in this method, you're finding the value of the R. It will have a formula for this, and we are finding the value of small r, and your value of r is lying in between +1 to -1, and that value tells you how much the strength of the association between two variables. Okay, also in Spearman's rank correlation method, you're finding the value of the rho. Rho is the notation we used for the rank correlation method. Also sometimes it is denoted by the capital R. So different notations can be used in different books for the same thing. Okay, so this correlation coefficient, rank correlation coefficient, also lies in between +1 to -1. So let's see more about the scatter diagram. So forget about what is written, the value of the R. Okay, so when you have the points and you are plotting the points on the graph, let's say let's see this first graph. This is your y, this is your y, this is your x. Yeah, and if you see here, all the points are in a straight line. Okay, you can draw a line passing through all points. That's why there is a perfect correlation. But the slope of the line is negative. It is going downwards. That's why you're assigning the negative sign. So you can say perfect negative correlationship exists between 2 points, two variables x and y. Because you can draw a straight line passing through all points. That's why you're saying perfect negative correlationship exists. And also the trend of the line is downward trend. Now in the next, here, this particular diagram don't tell you the value of R. This is calculated by the Karl-Pearson's correlation coefficient and just written down here. But the diagram just tells, diagram is like this, only this part you will have in the diagram. And it gives you the idea about whether there is a positive correlationship exist or negative correlationship exist. The value is not, you cannot calculate the value using the scatter diagram. Okay, so here again these points are plotted, and if you see that they are drawing a line passing through the points tentatively in the middle of all the points, and the line is with upward trend, right? The slope is positive, so you're saying positive correlation exists between x and y. In this diagram also, you can say upward trend, positive correlationship exists between two variables x and y. So in this diagram, now you can draw a tentative line like this. Okay, and you're saying as the line is downward, the trend is downward, right? So you're saying negative correlationship exists between x and y. So here, by looking at this, you cannot say anything about the correlationship. You can draw a line like this or this. It is difficult to say anything. So you can say no correlation exists between two variables x and y, because you cannot find out a single line, or you cannot find a trend in this particular diagram. But if you use the Karl-Pearson's correlation coefficient, it is giving you the answer 0.2. So very small positive correlation exists, but you cannot identify the correlation by using looking at the diagram or graph. So you can say no correlation exists. Okay, so in the last diagram, now you can draw a curve passing through all the points, right? So the two variables are related, but they are not linearly related. Okay, so there is a non-linear relationship exists between x and y. And what our R is calculating the linear relationship. So R is giving you value 0. Why it is giving you value 0? Though there is a relationship exists between x and y, but we are checking just linear relationship, and linear relationship does not exist between x and y. So you can say non-linear relationship exists, but what your R is telling you about the linear relationship. So the value of R is 0 because non-linear relationship exists and linear relationship does not exist here. So few more scatter diagrams. So again, we have plotted the points on the Cartesian coordinate system, and we are trying to find out whether positive or negative correlationship exists between two variables. So here, if you see in this diagram, the upward trend, you can see the upward trend, right? So you can say positive correlationship exists. Here also upward trend, the positive correlationship exists. But if you compare these two diagrams, okay, so if you compare these two diagrams, the points are more located near to the line here. And if you compare in this diagram, the points are more scattered here. That's why when the points are more scattered, weak positive correlationship exists, but weak correlationship exists because the points are scattered or located more away from the line we have drawn. So in the first diagram, if you say they are located around the line. So in the third diagram, you cannot say anything about in this diagram, okay. this diagram. So you cannot say anything about the correlation. You can say no correlationship exists. Again, downward correlationship trend is there. So negative correlationship exists. Here also negative correlationship exists. So in these two diagrams also, you can looking at diagram, you can say how much strength of the association. So here the strength is more because the points are more located around the line. Here they are more scattered. So in the last diagram, you can say weak negative correlationship exists between 2 points. So few more scatter diagrams. First is telling you positive correlation. The second is negative. The third one, no correlationship exists. And the fourth one, again, the perfect positive correlationship exists. So I think you're clear with the scatter diagram now. Again, by looking at this, first graph is telling you positive correlationship exists. Here positive correlationship exists, non-linear correlationship exists, right? So here perfect positive correlationship exists, excluding the two outliers ending points. So this is about the scatter diagram, and now we are learning the next method, that is Karl-Pearson's correlation coefficient. So are you clear with the scatter diagram? We are learning statistics and quantitative techniques, and this is unit 4, correlation. Your mentors always send you mail regarding which session is there. At least go through before joining, see what you are learning today. So the next one is Karl-Pearson's correlation coefficient. So we calculate the Karl-Pearson's correlation coefficient using the formula given below. So I have written here the computational formula for Karl-Pearson's correlation coefficient. So if you want to know the formula, it is covariance of xy divided by sigma x into sigma y. So sigma x is your standard deviation for x, standard deviation for y. And in the numerator, you have covariance of xy. So instead of using this formula, you can use this computational formula and directly find out the value for the R. Okay, so Karl-Pearson's correlation coefficient, we generally denote it by the small r. It always takes the value between +1 to -1, and it gives you the magnitude as well as direction. So when the answer for r is positive, you're saying positive correlationship exists. When the answer comes with a negative sign, the negative number is there in between 0 to -1, you're saying negative correlationship exists between two variables. And you can also get some value in between +1 to -1, giving you the magnitude of the association. So these are the values of the X and Y. The age and weight values are given for 6 observations. So your pair data, you have two variables, age and weight, and you are interested in finding the correlationship between the two variables, age and weight. So you're interested in knowing whether the age and weight, two variables, are associated with each other or not. If they are associated, what kind of association exists between them? Whether the age is more, weight is more, age is less, weight is less, or age is more, weight is less. What kind of association actually exists between two variables that you are finding here? Okay. With the help of following details in the table, the 6 people have different ages and weights given below for the calculation of the value of Karl-Pearson's R. Okay. So you're finding the correlation coefficient R. So this is the formula. I have already done the calculations. So if you want to do the calculations, you need number of small n is your number of observations. Okay, so how many paired observations you have? You have 6 paired observations. Don't get confused. There are not 12 observations. you have the paired observations. So XY is one set of the observations. So you have 6 observations here. Your N is 6. Then you need summation of xi, yi, that is, I have already calculated, minus summation of x, summation of y. And in denominator, you need n into summation of x square. So I have calculated the x square column, summation of it, y square column, summation of it. And I'm putting all the values in the formula and finding out the answer. And the answer is 0.35. So can you tell me what kind of correlationship exists between age and weight? By using the 6 paired observations, what you observe, what kind of relationship exists between age and weight? Positive or negative? There is a positive correlationship exists between X and Y, that is age and weight, okay? And the strength is 0.35. So weak positive correlationship exists between X and Y, you can say. Generally, when the value of R is more than 0.7 or 0.6, we are saying more than 0.7, basically, you are saying the strong positive correlationship exists. Otherwise, medium correlation, and more less than 0.4, you're saying the weak correlationship exists. So this is judgmental, okay? No thumb rule. You want to see this slide? So the next is Charles Spearman's correlation coefficient. So Charles Spearman's rank correlation. So whenever you have a data which you can rank, and you want to find out the association between two variables, that time you are using the Charles Spearman's correlation coefficient. So generally we use this in ordinal data. You know the ordinal data, we have learned it in the first session, maybe. So what is the ordinal data? When your data is qualitative or non-numerical, but you can arrange the data in orders, or you are measuring the quality, some quality. That time what you are doing, you are giving the how to measure a quality. There is no thumb rule, right? So you are giving the ranks. So for such type of a data, wherever the ranks are there in the picture, you can use the Charles Spearman's correlation coefficient. So this is also called as a rank correlation coefficient. Okay. So this is the formula for Charles Spearman's rank correlation coefficient. The formula is 1 minus 6 summation of di square upon n square minus 1. Now again, remember, we are in the correlation. So we have a paired data, right? And the difference between the ranks of the two data sets is your di. What is happening today? I'm unable to operate this. It gives you the idea about the association between the two variables, okay? And the regression is the next step of the correlation, where the regression evolved from the correlation. Basically, if you know there is association exists between two variables, you're interested in finding the relationship between, or the equation of the line in between the two variables, okay, which you can use for the prediction. And that is the main important importance of the learning correlation. So you are checking whether the variables are correlated or not, means whether there is any relationship exist between two variables or not. So the next step is whatever the line we are drawing in the scatter plot, that actual line is the regression line. Okay, so we are interested in knowing the equation for that regression line. So once you have the equation for the regression line, the regression is a technique we use for the prediction. Okay, so yes, sure, I shall upload it. I've already sent for from my side. I shall take a I shall check whether they what is the problem, why they have not uploaded with technical team, and I shall make sure that the video lectures are available to you on this VM, whatever the recorded sessions are. Okay, so the technique we use for the prediction is the regression, and regression concept base is the correlation. That's why we are learning the correlation. Okay. So here we are finding the correlation between the ordinal data, where the data is the ranked one. Okay. So find the rank correlation for the following data. So the data is given to you, your expected, now they are saying the rank correlation. So they have measured some of the qualitative data, and some results are in front of you. So you're expected to convert this data into the ranks, because it is clearly mentioned you're finding the rank correlation. Okay. So here, how to convert the data into ranks? So here you have the data X as the 10, 6, 9, 12, and 8. So what is the maximum number here? 12 is the maximum number. So you are giving rank 1 here. The second highest is 10. So the rank 2 here. The rank 3 for 9, 4 for 8, and 5 for 6. So if you see, your Rx is the ranks for R, and that are 2, 5, 3, 1, 4. Okay. So now let's find out the ranks for Y. So what are the ranks for Y? What is the highest number here? The 9 is the highest number, right? So you are giving the rank 1 here. The second highest is third, fourth, and fifth. Once you have the ranks, you are arranging them in the columns, and you are taking a difference between the ranks. Okay. So 2 minus 2 is 0, 5 minus 3 is 2. I'm here. Okay. 2 minus 2 is 0, 5 minus 3 is 2, 3 minus 5 is minus 2, 1 minus 4 is minus 3, 4 minus 1 is 3. But we are not interested in just knowing the difference. We want the difference square. So we are squaring the difference. 0 square is 0, 2 square is 4, minus 2 square is 4, minus 3 square is 9, 3 square is 9. So you are taking the summation of it, you're putting it in the formula, that 1 minus 6 summation of di square. Now 6 is in the formula. Okay. 6 is in the formula only. 6 summation of di square upon n square minus 1. So ultimately the answer is minus 0.3. So you can say negative correlationship exists between the two variables X and Y. Nagraj, do you have any query here? I'm just associating the ranks to the numbers, the highest number with the rank 1, the second highest with the rank 2, and so on. N is your number of observations. 1, 2, 3, 4, 5. Okay. Number of paired observations. How many paired observations you have here? That is your N. Di square is difference square. Summation of a difference square. So your formula is, try to understand the formula first. 1 minus 6. 6 is in the formula. Minus di square means difference of the rank square. Summation of the difference of the rank square divided by n is your number of paired observations. How many observations? Paired observations you have? 5. 5 square minus 1. Okay. So in correlation, whenever you're dealing with the n, that is the paired observations, number of paired observations you have. Don't get confused. So now this is one more example. We have following data of marks scored by students in two subjects A and B. Let's say you cannot generally use the numerical data for ranking. Okay, so if some quality is measured, that time we generally give the ranks. But for this example, you can try, this is just for your understanding. So highest rank is 85 here. The second highest is 78. So I'm giving the rank 2 here. So the third highest is 75, right? So I'm giving the ranks. This is the 1, this is the 2, this is the 3, this is the 4, then 5 and 6. But if you see here, these two numbers are repeating. So whenever you have such kind of a situation in front of us, you are taking the mean of the ranks and you're replacing both the places by taking the mean. So what is the mean here? 3 plus 4 divided by 2 is 3.5. So I'm writing the ranks 3.45 for both the numbers. Okay. So the next one is, what is the highest here? 86. So I'm writing the number 1 here. So this is the rank 1. This is the rank 1. Let's say this is 2, this is 3, this is 4, this is 5, and this is 5, and this is 6. But here again, 3 numbers are repeating, right? 80, here again 80, and here again 80. So we have to take the sum of all 3 ranks given to these numbers and taking the average of it. So 2 plus 3 plus 4 divided by 3 is 3. So the average, I'm replacing the rank by the average, that is 3. So here, instead of 2, I'm writing 3 because the average of 3 ranks, average of 2, 3, and 4 is 3. So I'm replacing all 3 ranks by the number 3. So now you have the 2 sets of the ranks, right? 1, 2, 3.5, 3.5, 5, and 6. And the second set is 3, 1, 3, 3, 6, 5. So now once you have the set, the rest of the thing is easy. So you are taking the difference, you're squaring the difference, taking the summation of it, that is 13.5 here. Okay, so how to find out the rank correlation? 1 minus 6 summation of di square and n square minus 1. So how many paired observations you have here? You have 6 paired observations. So 6 into 13.5 divided by 6 square minus 1, and your answer is 0.61. So you can say that there is a positive correlation exist between the two sets X and Y, and the association between the two sets is 0.61. So you are giving the ranks as per the like highest number, you are giving the rank 1. The second highest, you are giving the rank 2. The third highest, you are giving the rank 3. That way we can give the ranks. Okay. Can't you hear me? Am I audible? Yeah. So what you're doing, if you have the observations with you, the highest number of the observation, you are giving the rank 1. The second highest, you are giving the rank 2. The third highest, you are giving the rank 3, and so on. So if the ranks are repeating, okay, so in this case, like this case, okay, so when I'm giving the rank 1, so maximum number is 85. So I'm giving the rank 1 to the 85. What is the second highest? Second highest is 78. So I'm giving the rank 2 here. Okay. So I'm able to change the color. So this is the rank 1. This is second highest is 78, right? So 78, I'm giving the rank 2. But 78 is again, the third is 73. Okay, the third highest is 73. So I'm giving the rank 3 here. Again, the 75 is repeating one more time. So the rank 4 is here. So after 75, what is the next number? 64. So the rank 5 comes here. 6 is here. Now, if you see these two numbers are same, so you have to give them the same rank, right? But the ranks we have given 3 and 4. So what we are doing, we are taking mean of the ranks. 3 plus 4 divided by 2. That is 3.5. So what I'm doing, I'm replacing both the ranks 3 and 4 by the average of the two ranks. That is 3.5. Okay, so I'm replacing this 3 by 3.5 and also 4 by 3.5. So what is the set of the ranks I have now? 1, 2, 3.5, 3.5, 5, and 6. Okay, so in this case, the highest number is 86. So I'm giving 1. So the second highest is 80. So 2, again 3, 4. After 80, the next number is 74. So the rank for 74 is 5 and 72 is 6. Now in this case, 80 is coming 3 times. So you have to give the same rank, right? But what rank we have given? We have given rank 2, 3, and 4 to the 80. So what we are doing, we are taking the average of the given ranks. That is 2 plus 3 plus 4 divided by 3. So the average of this is 3, right? 2 plus 3 plus 4 is 9. 9 divided by 3 is 3. So what I'm doing, I'm replacing the ranks, the repeating ranks by the average, that is 3. So my new ranks are 3, 1, 3, 3, 6, and 5. So I'm using the given ranks for the calculation. Now I have two sets, 1, 2, 3.5, 3.5, 5, and 6. And in the second set, the second set is 3, 1, 3, 3, 6, and 5. So now I can find out the difference. I can square it. I can take a summation. And the answer is 13.5. Okay. So now I'm using or putting this in the formula. So what is the formula? 1 minus 6 summation of di square upon n square minus 1. So here 6 into 13.5 divided by how many number of paired observations you have here? You have 6 paired observations. So 6 square minus 1. So your answer is 0.61. Clear with this? So here we are done with the unit of the correlation. If you have any query in this unit, you can ask me now. This is correlation, unit 4. We are learning statistics and quantitative techniques, and this is unit 4 we have just covered. And now I'm starting with the unit 5, that is simple and multiple regression. Though we'll not finish the unit in this session, I'm just introducing you to the regression so that we can continue in the next session with the regression. When you go for the regression, there is it is not mandatory to find out the correlation. Without correlation, you can directly go to the regression. But if you know that there is association exists between two variables or not, it will be easy for you to find out the regression. So when it is not that you cannot find the regression between two variables. Okay, you can find it, but the question comes whether whatever the regression model you are fitting is best fit or not, whether it is useful or not. That is the question. So for that purpose, you have to find out the correlation, or you have different tests for regression equation, whatever you fit the regression equation between the two variables or two or more variables. You have the test whether the this model is good for the prediction or not. So it hardly matters how many digits you are countable after the decimal. In this, according to whatever you are learning, whatever more interesting and more interested is for you, or for examination point of view, if you're asking me, I shall not ask you the detailed questions to solve the examples in the examination. You will have the simple MCQs, and you have to interpret whatever the given in the data, or whatever the equation if I have given. So I shall ask you, what is the regression coefficient in this equation? So such type of questions depend on your understanding. You will find out in your final examination. So I shall not ask you to do the so many calculations, but definitely in multiple choice multiple response session you have to do the calculations. And mostly I shall ask the mean, mode, median, standard deviation, variance calculations in that session. So we are done with the unit correlation, and then we are learning the next unit, that is the regression. Okay, simple and multiple regression. So this is unit 5, simple and multiple regression. So what is actually the regression? The technique of prediction on the basis of correlation is called the regression. Once you know there is some relationship exists between two variables, in the correlation, you are using that relationship for the prediction, and that technique is the regression. Okay. So regression technique concerned with the predicting some variables by knowing other variables. So in regression, you know the value of few of the variables, and on the basis of those variables, you are predicting the value of the another variable. And the technique is the regression. But for that purpose, you must know what is the relationship exists between two variables. Okay. The process of predicting variable X using the variable Y using the X tells you the value in Y change as the function change with the value of X. So let me explain you this. So if you have two variables like X and Y, you have two variables X and Y. Okay. So let's say X is height and Y is weight. So I'm taking the simple example. Let's say the height is 4 feet, 4.5 feet, 3 feet, 5 feet, and the respective weights I'm writing, let's say 20 kg, 21 kg, 15 kg, 22 kg. Okay. So you have the values of X, you know the values of Y. So this is in kilograms and this is in fits. Okay. So if you know you have such type of a data with you, so you have the value of X, values for the variable X, values for the variable Y. So you have the pair data. Okay. Here also you have a pair data. So I'm explaining you simple linear regression. So first try to understand the simple linear regression, and then we will extend the simple linear regression to the multiple regression for understanding. Okay, so if you know the next value of X, let's say you want to know the value of the weight for the person with the height 4.2 feet. This data is available with you. Okay, this data is available with you. And some next, either of one of the variables data, like 4.2 height. Using this data, you can find out the equation X on Y. That is, value of X depends on the value of Y. And so it will like X is equal to A plus BY. Okay. So this is one of the relation you will have. So let's say B1Y. This is A1, B1. So you can find one more equation of the line, that is Y on X. So you will use this when the value of y depends on the value of x. So when you know the value of x, like in this case, you know the next value of x, right? So you are interested in knowing the value of the y. So your x is independent variable. What is independent variable? You know the value of this variable. This value does not depend on any other variable. So value of the known variable is independent variable. But you are predicting the value of y when you know the value of x. So value of y depends on the value of x, right here. So in this case, your y becomes dependent variable. Dependent variable. So you will have the regression equation like y is equal to a2 plus b2x. So you will have this equation of the line. You are using this equation for the prediction of the value of the y when the value of x is given. So you know the value of x, you are putting the value of x here, you know the a2, b2, and you are just doing the calculations and you are predicting the value of y. That is the regression equation y on x when you know the value of x and value of y depends on the value of x. Okay, so when the value of y is given to you, let's say the weight is 18 kg and you're finding for weight 18 kg, what will be the height of the person if the weight is 18 kg? This is not a fixed value, okay, but tentatively it will give you the correct value. The prediction is always the tentative. You cannot guess the perfect figure, but tentatively nearby figure you will find using the regression. So if your model is best fit, that then only you can your prediction is the perfect. So x on y, so you know, if you know the value of x, sorry, the value of y, like a value of y is 18 kg, and you are interested in knowing or predicting the value of x when the weight is 18 kg. Okay, so that time you have to use the regression equation x on y. That is the value of x depends on the value of y. That is x is equal to a1 plus b1y. So you will have to, this is your intercept, this is your regression coefficient. And if you know the value of y, you're just putting the value here and you can predict the value of x. And that technique is the regression. So this is about the simple regression. Okay, so you have set of paired observations. Using the set of paired observations, you are finding the regression equation, and using that regression equation for the prediction purpose is the regression analysis. Okay, so if you are interested in finding the value of the y when the value of the x is known to you, you are using value of x is known and value of y you want to find. So the value of y depends on x. So you are fitting the regression line y on x. Okay. And when you know the value of y and you are predicting the value of x, so you're predicting the value of x now, right? So value of x depends on the value of y. So x on y. So you need the regression equation x on y. So accordingly, you need two different regression equations when you know different variables. Okay, are you getting these things? You cannot use the same regression equation for the predicting both the variables. If you know the x and the value of y is unknown to you, your y value depends on the value of x, so you need to find out the regression equation y on x. And when the value of x is known and you are predicting value of y is known and you're predicting x, you're fitting the regression equation x on y. So these are two different equations. You have two variables here in each of the equation. One is dependent and one is independent. So the value for which variable you variable's value you are predicting becomes your dependent variable, because you are predicting the value and its value depend on the another independent variable, and the another variable whose value is known to you is your independent variable. So we have the formula for determining A and B. Okay, So you will have different A1, B1 and A2, B2 are different numbers in both the equations. These values are not the same. Okay. So there are different lines of equations. We have the formula to find out A and B. But this is just the overall concept of the regression. So you have the paired variables. So I'm talking about simple linear regression. I'm talking about simple linear regression, and not about the multiple regression where more than two variables are involved. I'm just talking about the simple linear regression. Okay. So in simple linear regression, you have two variables, X and Y. And using the variables, you are finding the equation of the regression line. If you are predicting X, you have different regression equation. If you are predicting Y, you have different linear regression equation. So correlation describes the strength of linear relationship between two variables that we have seen. Linear means straight line relationship. So regression tells us how to draw a straight line described in the correlation. So where we have described the straight line in the correlation. So whatever the line equation of the lines we have, so this is the way we were plotting the points, and we are saying that we can draw a line passing through, tentative line passing through the points. So this equation, this is the regression line basically. The line which you are drawing in the scatter plot, tentative line, if you want to find out the perfect equation of the line, that line you are drawing in the scatter plot, you can find out the equation of that line using the regression equation. Okay. It calculates the base fit line for the certain set of data. The regression line makes the sum of squares of residuals smaller than for any other line. So like in this case, okay, so these are the points. So I can draw a line like this, or I can draw a line like this, or I can draw a line like this. So all the lines are correct, right? But we are interested in finding out the line whose distance is minimum from all the points. Okay, so if you have different points like this around the line, you are finding this distance. These are the residuals we are saying. And this distance, you are adding this distance. And if you are plotting the line, and you are interested in knowing the equation of the line where this distance is minimum. So regression line makes the sum of squares of residuals smaller than any other line. So you are interested in knowing such a line around which the points are scattered in such a way that the squares of a residual is smaller. So this is the regression model we have. Yi is equal to beta naught plus beta 1 x plus random error. So we are not considering the random error part now. So we are just interested in fitting the simple regression model. Y depends on, this is the regression equation for the line y on x, right? The value of y depends on the value of the x. So you have beta naught, you have beta 1 x1. So the value of x is known, and you are predicting the value of y here in this case. So your x1 value is known to you, x value is known to you, right? Basically, the next xi value is known to you, and you are interested in predicting the value of the y. So in that case, you can use this model. Y is equal to beta naught plus beta 1 x. Okay, so y becomes your dependent variable, x becomes independent variable. So beta 1 is a slope coefficient. We called it as a regression coefficient also. And your beta naught is the intercept. So when you draw a line on the graph, intercept is a point where your line intersects your y-axis. Okay. So we have two regression lines, X on Y and Y on X. Okay, so this equation, we can find out like X minus X bar is equal to B